It's me, Mr. Truman again. Making a quick little video here. I was gonna go over a quick concept with us that we covered in class the other day, but I was asked to make a quick video to just kind of recap it. And what we're gonna do is go over how to identify whether or not lines are parallel by using a graph, and how to identify if they're parallel by using an equation. And then the same thing goes with perpendicular. We're gonna look at how to look at perpendicular lines in a graph and tell that they're actually perpendicular, and if they're perpendicular in equation form. So we're going to jump right in and talk about what it means to be parallel. So as we talked about in class, parallel means lines that do not intersect. More specifically though, it means lines that do not intersect that are on the same plane. So the two lines behind me here that we're looking at, these are lines that are on the same plane. And if you look at them closely, you can see that they do not intersect. So they're parallel lines. Now, what I want to explain to you is why they're parallel, why they're never going to intersect. And it has to do with their slope. By definition, the slope of parallel lines has to be the same. Two lines that have the exact same slope are parallel. So the reason that happens for us in a graph, if we take a look at it, if we measure the slope on these two lines, you'll see that they have the same rise-run ratio, which means because they're not located at the same y-intercept, the fact that they rise and run at the same amount each time is going to make it so that one line will never intersect the other line. So I'm going to jump right in with how I count slope. I like to do slope when I have a graph. I always want to tell the kid to go ahead and use the counting method. We will look at the formula in the next one, but right now I want to focus on the counting method. And I do that by using the rise, run, and basically just building little staircases. So I'm going to jump right in with, I need to place a couple dots on the line so that I can trace out a rise, run. So when I'm looking at the graph, I'm going to look across the line, and I'm going to call this line, I'll make this one line A, and this one line B. And when I look at line A, I'm looking for a place where the lines going vertically and horizontally and the blue line all come together, because that's a place that I want to put a dot. So when I look across there, I can see this is a good one right here. There's nice. Right there on the y-axis, I can see that the horizontal, vertical, and the blue line all come together. And maybe if I come over here and I look from that position, I can see right here that there's another one right there, and another one right there, and here, and here. Well, if you take a pencil and you put it on one of those dots, and you use rise, run, you can see that I have to rise 1 and run 2. 1, 2. And I rise 1, run 2, rise 1, run 2, all the way across the page. So I know that the slope of this line is 1/2. All right, well, the same thing goes with line B. If I look at the line and I kind of just look for the places where the horizontal, the vertical lines come together, and along with my blue line, I can see that there's several places along the way that I can draw dots or draw some points. So by doing that, and I can put my pencil on any of them, but if I do that, I can see I go up 1, over 2, and I could go back 2 and down 1, which is the same thing. And I see again that I'm having the same slope. M is going to be equal to 1/2. Well, because these two are both located at different points on the y-axis, there's no way they're ever going to intersect, because each one of them moves across the page at the same rate. Rise 1, run 2. So these two lines are parallel, and we would write A is parallel to B. So I'm going to go to the next example, and it gives us a picture, but I'm also going to use the formula. So on the side here, I'm going to use my blank space on the side, and I'm just going to write real quick that slope is equal to the difference of the y's and over the difference of the x's. And this gives us our change. Our formula is the change in the y values, the rise, over the change in the x values, which is the run. So looking at the next example, they gave us some numbers. And what I want to do is I'm going to plug in those numbers into my formula, and I'm going to calculate my slope, because something's odd here. I notice the distance between these two dots seems to be different than that. but yet the two lines don't look like they intersect. So I want to make sure that they really do have the same slope. So I'm going to kind of highlight these two. And then I need to give them I need to assign each of them a value of x1 and y1. So I'm just going to call this one x1 and this one y1, and this one x2 and y2. Now if I use this formula and I plug in these numbers, let's see what we get here. We've got 5 take away 4, or 5 minus 4 over 5 minus 3. Okay, so 5 minus 4 is 1, and 5 minus 3 is 2, and it's telling me the slope is 1/2 if I use the numbers. Well, let's check that on the graph. Rise 1, run 2. Well, sure enough it is. And if I can go back 2, down 1, back 2, down 1, all the way across the page, it looks like that slope is really the right slope. It's 1/2. So what's up with the second one though? Because the numbers seem to be separated more. So something's kind of weird there, and I'm going to figure this out real quick. What's going on there? Because the lines, to me, they look parallel. They don't look like they're ever going to intersect. But yet somehow they've separated these dots a little bit, these points. So maybe something's going on there. So let me check, and I'm going to do the same thing. I'm going to give them some values. I'll call this one, you know what, I'm going to switch it up because I hate when people think that the first one always has to be. So you know what, just to be annoying, I'm going to swap these. Because I don't want people fixated on the fact of which one has to come first. It don't matter. You're just finding the difference between the numbers. It doesn't matter which one comes first. Just make sure that you call it x1, x2, x2, y2. All right, so I'm going to do that one there. Let me do that same problem. What have I done? All right, so let's see here. I'm going to go, according to the formula, it's 1 take away 3, or 1 minus 3. I'm intentionally making negative numbers just to be annoying. 1 minus 3, and then 2 take away 6, or 2 minus 6. So let's see, 1 minus 3 is negative 2. 2 minus 6 is negative 4. And sure enough, they do have something about 2 and 4, but let's think about this for a moment. What's negative over a negative? That's a positive. And could I reduce 2/4 to a smaller number? And that would be 1/2. So let's double check. They're telling me that I got a rise run of 1/2 according to the numbers. So let's go to the graph here. Well, sure enough, if I go up 1 and over 2, I land right on that line after all. Same thing here. 1, 2, 1, 2, 1, 2, all the way across the page. So the slope is the same. These lines are parallel. So if I were to give them a name and say that this one's going to be line, say L, and this is line M, I would say L is parallel to M. And so this is how we use the slope formula though to calculate. And then again, I like to just do it by counting. But if I ever get in a situation where I'm not 100% sure, I'm going to go right to the points and I'm going to make sure that my points work out. All right, let's look at a problem in which we have, for example, 2 lines that are given to us in equation form. Well, now I need to know if they're parallel, perpendicular, or neither. And so far, I've only covered parallel in this video, so I hope they're parallel, because if not, I'm not sure what I'm going to tell you. But let's see why they probably are going to be parallel, since I obviously loaded this up that way. When I look at the 2 lines, the first thing I notice about the line on the left-hand side is it is in what you call slope-intercept form. It's y equals mx plus b. So because of that, I know in this case, because it follows this format, I know that over here on the left side, my slope value is 3/2. That is not a 3. There it is. Even a little bit better. No, that's not going to work. I got to do better than that. So, three halves. All right, that one's easy. I know that one's 3/2, but over here I've got a bit of a situation because see now this one isn't really in slope-intercept form, which means I don't really know if it has a slope or what the slope is. I really don't know what it is at this point. So what I'm going to do is I'm going to need to do a little bit of work on this one, and I'm going to have to convert this into slope-intercept form. And so I'm gonna do that by starting with, I'm gonna subtract 3x from both sides, because when I want slope-intercept, I'm just trying to get this y all by itself. So let me see, I'm gonna bring down what I got. Since I got rid of the x's, I moved them to the other side, and I wanna keep that format, so I'm gonna bring down 3x, and then it looks like I got a minus 14 or a subtract 14. All right, well, let's go back and see. Now, I still am not in the y equals format, but I'm real close. If I divide by -2, now I've got y equals, and now let's stop and think here. Wait a second, we got a negative over a negative, so I know that's a positive. And 3 doesn't divide by 2, at least not evenly. And I really want this number to be a fraction anyways. So I'm just gonna write 3 over 2x. And then the last part, the negative 14 over the -2, that's positive 7. I'm not really too worried about the 7, just like I wasn't too worried about the 5 over there. I'm only interested in one thing, and that's the slope. And when I look at these both have a slope of 3/2. And so according to this, it looks like these lines, looks like when I compare the two, turns out they're parallel. They have the same slope.
Good afternoon, student staff. Here are some announcements before we break for the day. Did you know that 2 of the 7 remaining U21 players of the 2020 Junior Speed Chess Championship are